Good day, my viewers and listeners, once again. Welcoming you to another class, which is a chemistry class. And today, in our chemistry class, what we shall be discussing is isotopes and isotopy. Having discussed in the previous class, we talked about atoms. We talk about the particles that make up, subparticles that make up an atom, which are proton, neutron, and electron. So today we shall quickly look at isotopes and isotopy. As you have it on the board, isotopes are atoms of the same element with the same atomic number, that is, the same number of protons, but different mass number, that is, different number of neutrons. So what we talk about isotopes are atoms of the same element. For instance, if you have oxygen, so atoms of the element oxygen could have the same number of protons but different neutrons. When such a situation occurs, it is regarded as isotopy. So what we call isotopy is a phenomenon whereby atoms of the same elements have the same atomic number but different atomic mass. So you can say isotopy is a phenomenon whereby atoms of an element have the same atomic number but different mass number. So when that occurs, it is regarded as isotopy. So take note. What is responsible for isotopy? Differences in the number of neutrons is what is responsible for isotopy. For example, let's talk about oxygen. We can have oxygen 16. We can have oxygen 17. We can have oxygen 18. These are isotopes of oxygen. Oxygen 16, 17, and 18. If you look at this, the atomic number remains the same, but the atomic mass are different. This one has 16 as the mass number, which is atomic mass. This one has 17, while this one has 18. So if you have to break down the subparticles of this oxygen, that means in this oxygen we have 8 protons, we have 8 electrons, and then we have 8 neutrons. Don't forget, you subtract the number of protons from the number of mass number in order to get your neutron. For this isotope, the proton is 8, is the number of the atomic number. The electron remains 8, while the neutron is 9. So we subtract atomic number from atomic mass, it will give you the number of neutrons. For this isotope of oxygen, the proton here is 8. The electron is 8. While the neutron is 9. So take note. Neutron number causes isotopy. So the difference in the number of neutrons is what causes isotopy. All elements have isotopes. All elements exhibit isotopes except fluorine. Only fluorine does not exhibit isotopy. But it has been found out that all other elements exhibit isotopy. Let's consider further examples. All right. On the board we have other example. We have chlorine 37, chlorine 35. In this chlorine, the number of proton is 17. The number of electron is 17. The number of neutron is 18. Just subtract the atomic number from the mass number. That will give you the number of neutron. For chlorine 37, the proton is 17, electron 17, neutron is 20. Carbon has 3 isotopes: carbon 12, carbon 13, carbon 14. Carbon 12 has 6 proton, 6 electron. Neutron is also 6. Carbon 13 has 6 proton, 6 electron, but the neutron is 7. Carbon 14 has 6 proton, 6 electron, while the number of neutron is 8. So this is what is regarded as isotopy. So you can see the difference in the neutron. So difference in neutron number is what is responsible for isotopy of elements. All right. On the board we have hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 1 is called protium. Hydrogen 2 is called deuterium. Hydrogen 3 is called tritium. This is called tritium. This is called deuterium. Why this is called protium? Call it protium or proton. So in hydrogen 1, the proton is 1. The electron is 1. The neutron is 0. So no neutron in hydrogen 1. Because 1 minus 1 will give you 0. In hydrogen 2, the proton is 1. The electron is 1. The neutron is 1. In tritium, the proton is 1. Electron 1. Neutron is 2. Okay? I want to believe that is understood. On the board are the isotopes of sulfur. Isotopes of sulfur. We have sulfur 32. In sulfur 32, the proton is 16. The electron is 16, and as well as the neutron 16. In sulfur 33, the proton is 16, electron 16, neutron 17. In sulfur 34, proton 16, electron 16, neutron 18. In sulfur 36, proton 16, electron 16, neutron is 20. So these are the isotopes of sulfur atoms. Sulfur atoms. All right, now we are going to consider isotopes of ions. Isotopes of ions. Stay tuned. So right away we want to look at how atoms and ions differ in their subparticles under isotopes and isotopy. Don't forget that isotopes have been defined in terms of atoms of the same element, which are the same in atomic number but different in atomic mass. But when we talk about ions, ions are formed from atoms. Ions are formed when atom loses electrons. So the number of electron loss will determine the electric charge that the atom will carry when it forms ions. So ions are formed when atom loses electrons or gains electrons. So take note, ions can be formed when electrons are lost or when electrons are gained. When electrons are lost, the ion that will be formed will be positive ion. But when electrons are gained, the ions that will be formed will be negative. So as you have it, ions are electrically charged particles. Like on the board now, we have chlorine minus and we have oxygen 2 minus. In this instance, this gains electron. Chlorine gains 1 electron, that's why it carries negative charge. Oxygen gains 2 electrons, that's why it carries 2 minus. This one stands for 1 minus, but we don't write 1 as a superscript or as subscript. So in this chlorine, this is a ion, not atom. What is the atomic mass, the mass number? The mass number is 35. What's the atomic number? The atomic number is 17. And don't forget, atomic number is as well as the number of proton. Alright, but in this case, this chlorine has gained 1 electron. Definitely its number of electron has increased. It cannot be 17 again. So that will be 18. The number of neutrons remain unchanged. That's also 18. We subtract 17 from 35. So when atoms forms ions by gaining electron or losing electron, the only thing that is affected is the number of electron. It is the number of electron that will either increase or decrease. Other things, proton, neutron, atomic number and mass number are not affected. Let's look at chlorine 37. The atomic mass is 37. Atomic number 17. Number of protons 17. Number of electrons, it has gained 1 electron. That's 18. And then the number of neutron, that's 20. Oxygen 16. Atomic mass 16. Atomic number 8. The number of proton 8. The number of electron, add 2 to this, that's 10. While the number of neutron is also 8. For oxygen 18, that means atomic mass 18, atomic number 8. The number of proton 8. The number of electron 10. While the number of neutrons, subtract 8 from 18. That is 10. That is 10. I want to believe that is clear to everyone. Before we bring the class to a close, we quickly want to consider copper. Copper 63 and copper 65. Copper 63 and copper 65. Okay. So copper, as we know, it can be +1 and it can be +2. So this can be copper 1 and it can be copper 2. In copper 1, that means 1 electron is lost. So in that instance, the atomic mass is 63, atomic number is 29, the number of proton is 29. So copper 1 has lost 1 electron. So there's going to be a decrease in the number of electrons, which is 28. While the number of neutrons, subtract 29 from 63. That's going to be 34. 34. For copper 65, which is still copper 1, atomic mass is 63. Atomic mass is 65 rather. Atomic number is 29. The number of proton is 29. It has lost 1 electron, that's 28. So the neutron number will be subtract 29 from 65. That's 36. For copper 2, atomic mass 63. Atomic number 29. Yes. Proton 29. So the number of electrons has decreased by 2. That's 27. So subtract 29 from 63. You subtract 29 from 63. That's going to give you 34. For copper 2 plus, which is copper 2, 65 atomic mass, atomic number 29. So we have 65 as mass number. You have 29 as atomic number. The number of proton is 29. So it has lost 2 electrons. That's 27. The electron number will decrease. So the number of neutrons, subtract 29 from 65. That's 36. That's 36.